Okay, here we go. So 2.3 is more solving linear equations problems, but these ones we're introducing a few things that make them a little more challenging. And the first thing we're going to deal with is called fraction clearing. And this is a way to deal with a problem like this that has a bunch of fractions in it. And it's sort of a first step. And the idea is I'm going to multiply both sides by something and by a special number, and that number is going to help me get rid of all of my fractions. So I want to find a number and multiply both sides by it to get rid of all fractions. So to get rid of all fractions. And so the way I'm going to find this number is I'm going to choose the least common multiple, or it's the same method you would use to find the lowest common denominator. So I'm going to I start by finding the least common multiple of all denominators. So denominators are the things that are in the bottom of fractions. So what I have here for denominators, I have a 2 and I have a 3. So when I'm looking at this, I have 4 terms. This one's a fraction. This one is just a number by itself. This term is a fraction, and this is just a number by itself. So the only denominators I have are that 2 and that 3. So I'm going to find the least common multiple, and I've talked about this a little bit, and if you've done that fraction review, you've seen some of this too, but I'm going to look at multiples of 2, 2, 4, 6, 8, 10, and then I'm going to look at multiples of 3, 3, 6, 9, 12, and what I want is to find the first number that is on both of those lists. So 6 is on both of those lists. That is what I'm going to use. So I'm going to take that number and multiply both sides by it. So here, this whole side, I'm going to multiply by 6. This whole side, I'm going to multiply by 6. And now that's going to distribute to all of those terms. So here's what happens. I end up with 6 times x over 2. And because I'm multiplying by a fraction, I'm going to think about that as 6 over 1. And that then is getting multiplied by x over 2 minus 6. And now there's no reason for me to think of 6 as a fraction, so I'm just going to think of it as 6 times 1. And then that is equal to, over here, that 6 goes to both of these terms, so I have 6 over 1 times 2/3 x minus, and then the 6 times 3. Now I can go through and simplify all these, and what's going to happen is my terms with fractions, I'm going to have some nice simplification with my upstairs, downstairs. Here I have a 6 upstairs and a 2 downstairs, and what's going to happen is that because 6 is 2 times 3, that's going to cancel to a 3, and that's going to cancel to a 1. Over here, this is going to cancel to a 2, and that's going to cancel to a 1. And so what I end up with is 3 times x minus 6 times 1 is just 6, and that equals 2 times 2x minus 18. And now I can go through and, okay, simplifying that one term, that gives me 4x minus 18. And now I just have a relatively straightforward problem like one you saw in 2.2. So I'm just going to subtract 3x from both sides here. And so there's some work in this process of clearing the fraction, but the idea is that it's a step. It's kind of a complicated step, but once you take it, then you end up with a problem that is free of fractions. And so that should be an easier situation. And then let's go over here, and I end up with, what, 12 equals x. So that is my final answer. Okay, and a lot of the problems in the homework are going to have that fraction clearing step. I'm going to scroll down here. So this is a big list of steps for solving linear equations. And the first step is, if you have fractions that need to be cleared, clear them. So, if necessary, clear fractions by multiplying both sides by the least common multiple of all denominators. And a lot of problems don't have fractions, so then you just don't have to do that step, and that's what the if necessary is about. Next, if necessary, again, maybe this won't even happen, if necessary, use the distributive property to rewrite both sides of the equation without parentheses. My third step then is combine like terms. On each side. And so you've done a lot of these problems at this point, and you cannot combine like terms if they're across the equal sign. So you can't just add things that are on opposite sides of the equal sign. So this is about taking the sides kind of one at a time and getting them taken care of. These first steps here, these 3 steps, these are all the process of simplifying. So once you've got both sides completely simplified, then you're going to go through and do the 2.2 stuff of getting the equation, getting that x totally isolated. So your first step there is get all the variable terms on one side and all the constant terms on the other side. So get all variable terms on one side and all constant terms on the other side. And you're going to do that using the additive property of equality. So before you start multiplying things, you want to use adding things to both sides to get it so you just have variables on one side, just numbers, constant terms on the other side. So you're using the addition property of equality. Little box around that. There we go. Okay. And now you've got yourself in a situation where you just have like some number times x equals some number. And this is where you use the multiplication property to fully isolate that variable. The multiplication property of equality to fully isolate the variable. And then once you're done, you can always check yourself, which is a good idea. You can take whatever your solution was and put it into the original equation. So check your answer in the original equation. Okay, so those are the steps. I'm going to go through these 3 examples, and then there's a bunch of problems for you guys to do on the next page. And I'm going to give you a little bit of setup help in this video, but then I'm just going to post those answers on D2L, and we can talk about them in class or in any of the tutoring sessions or my office hours. So here we go. Here, I don't have any fractions to take care of. So this is nice. I don't have to deal with my step 1 because I don't have any denominators. But my step 2, I do have some parentheses. So the first thing I'm going to do here is use the distributive property to rewrite this without parentheses. So that 8 is going to go to the first term. It's going to go to the second term. I have 8 times 2 minus 8 times t, and that is equal to negative 5t. Now I'm going to simplify this whole thing. 16 minus 8t equals negative 5t. And now if I look at what's happening on both sides of my equal sign, I've got some variable terms over here, but also some variable terms over here. So I have one side that has more than one kind of term. I want to use the addition property to make that not the case. So here I'm subtracting 8t. I am going to add 8t to both sides. And that is going to give me 16 equals 3t. And now I'm always trying to get my variable isolated. So this is what I'm after. I'm after this t. That t is connected to the 3 by multiplication. So I can get that 3 out of there by dividing by 3. Dividing by 3. And I end up then with 16 thirds equals t. And that's a fraction, but that's okay. So I have 16 thirds equals t. Okay, here's another one. Now I have fractions again, but I've just got one denominator. So my only denominator is 3. And this you can think of, this is just one big fraction with this whole mess in the numerator and then just a 3 in the denominator. So to clear that fraction, all I'm going to do is multiply both sides by 3. And one common place that people will make mistakes in this fraction clearing thing is just multiplying, so here's what can happen is people think, well, I want to get rid of that 3, so I'm going to multiply this side by 3, but I don't have to do anything over here with fractions, so I'm just not going to. But the only reason I'm allowed to just run around and start multiplying things is because I'm allowed to multiply both sides by the same thing. So if I multiply by 3 over here, I have to also multiply by 3 over here. So what happens then is on this side, I have 3 over 1 times 2 times a plus 3 over 3. So this 3 upstairs and this 3 downstairs, this 3 upstairs and this 3 downstairs cancel out. Over here, there's no downstairs to cancel that 3, so it is going to distribute to these two guys. And I end up with this. On the left, that 3 canceled, so all that's left is 2 times a plus 3. Over here, I have 3 times 6a plus 3 times 2. And now I'm going to do, this next step is going to be about distributing this 2 like that. So I end up with 2a plus 2 times 3. And then over here, I'm going to simplify these terms. So I have 3 times 6 is 18a plus 6. And now I'll get this left side simplified. 2a plus 6 equals 18a plus 6. And then I'm going to use the addition property, so I have just variable terms on one side, just constant terms on the other side. So now I want to, I have two options. I could either subtract 2a from both sides, or I could subtract 18a from both sides. And I'm going to do 2a, and the reason I'm going to do that is because looking down the road a little bit, if I subtract 18 from both sides, I'm going to end up with a negative over here. And that, it's not the end of the world, but I can make my life a little easier by avoiding those negatives and doing it like this. So I have 6 equals 16a plus 6. Now I'm going to subtract 6 from both sides. And I get 0 equals 16a. And now people, this is, when people see zeros, they can start to panic a little bit, but that's okay. I'm just going to go through. A is connected to 16 by multiplication. I divide by 16. I divide by 16. Now, what is 0 divided by 16? I cut a pizza into 16 pieces. I don't give you any. You have no pizza. So 0 equals A. That is a problem that has a solution. This has one solution. The solution is 0. There's one number that makes this true. If I substitute 0 for A, I get a true statement. We'll see some problems later that don't have solutions, which is kind of a weird thing. And sometimes students get mixed up about there being a solution that is nothing versus not having any solutions. Okay, so one more example. This one is dealing with decimals. And what you can do, so clearing decimals is a little more optional. Sometimes students prefer to just go through and not just do the whole thing with decimals. But I'm going to talk about how to clear them. So here, this is, remember in decimals, the first place after the decimal is the tenths, then the hundredths. So the furthest my decimals go here is to the 100ths place. So I can clear these by multiplying both sides by 100. So I can clear these decimals by multiplying both sides by 100. When you do this, this is a time where it's pretty critical to be aware of how many terms you really have. So here I have one term here, I have one term here, I have one term here. Now when I take both sides here and multiply by 100, this is what happens. I have 100 times this whole side, which contains two terms. The first term is 0.25x. And then the second term on this side is 0.10 times x minus 3. And then on the right side, I haven't done that distribution yet. On the right side, I have 100 times just the single term over there of, so times 0.05 times 22. Now I'm going to perform this distribution. So this 100 is going to go just to these two terms. And the terms are things that are separated by that plus sign that's on the outside. And so people sometimes get confused and think that this is going to break things into terms, but this subtraction is happening inside of this term. So I have 100 times that first term, 0.25, it's really easy to lose those decimals, x plus 100 times 0.10 times x minus 3, and that whole thing is equal to, and I'm just going to rewrite this for now. Okay, now I'm going to start doing some multiplication, and I'm going to start my multiplication on each of these terms from left to right. So that means I'm going to do 100 times 25 100ths, that's 25 times x, plus 100 times 10 100ths, just multiplying left to right, that gives me 10, and then that's going to get multiplied by x minus 3. And that whole thing then is equal to 100 times 5 100ths is just 5, then times 22. And now I'm doing pretty well. I just have this little bit of distribution to do, and I end up with 25x plus 10x minus 30 equals 5 times 22 is 110. Now, and this hasn't been the case in some of the previous problems, but I do have some like terms I need to combine here. 25x and 10x, so I have 35x minus 30 equals 110. And now I can start trying to get the variable terms isolated. I have constants on both sides, so I'm going to add 30 over here so that all my constants are on the right side of the equal sign. I end up with 35x equals 140. I'm going to divide both sides by 35. And that doesn't necessarily seem like it's going to totally cancel out, but if you try it on your calculator, it's true. 140 is 140 divided by 35 is just 4. All right, there we go. So next page. All right, so the next page we have a bunch of problems, and I just want to give you a heads up about your strategy here. So this one is almost exactly like that first example I did. So you want to look at your individual terms. I have this term, this term, this term, this term. 2 of those terms are fractions, so I'm going to multiply both sides by the least common multiple of 3 and 5. And I'm going to let you guys get that figured out. These ones, you don't have any of that kind of fraction confusion to do. But going down here, this one is a lot like that other example where I just have one fraction with kind of a lot going on in the numerator, but I only have one denominator. And then I just want to warn you, and I want you to go through and do these problems and see what happens before you look at the answer. But 5 and 6 are weird. These two have weird answers. And so go through, see what happens, but if you get something that seems real crazy, don't panic. Just try to think about what that might mean, and we'll talk about those a little bit more in class or during the tutoring sessions, because it is sort of a strange situation, but I want you guys to get in there and see what happens on your own. Okay, that is it for the 2.3 notes.